So let's get started. Let's talk about what we're going to talk about today. So this webinar in general, the idea of talking about blower doors for diagnostic testing, it's written and sort of designed for people who do know what blower door testing is. But we are going to cover the real basics before, just at the beginning. But generally it's about people who understand blower doors but are looking to find out a little bit more about blower doors. So they know what they are, but they're curious about other ways that they're used and perhaps other ways that they can use them. So with that in mind, let's go through the session objectives. First one is that we're going to be talking about testing for energy code compliance or envelope performance, which is obviously a very big deal throughout the United States over the last year or two. The energy code has changed significantly in many states, and Joe is going to be talking a little bit about that. So once we talk about how that works and why that's important, then we're going to move on to just setting up your gauge for code compliance and a little bit more about what the gauge and that gauge that we're going to be talking mostly about is the DM32. Then we're going to go on to talking a little bit about best practices for blower door tests, how to make sure that they're repeatable, how to make sure that they're reliable, and how to make it easier and faster for you. And then we're going to talk a little bit about, and this is going to be kind of a thread throughout the conversation, about overcoming common testing issues. And so we'll talk a little bit about that. And then we might get into, if we have some time at the end, where some of the most common envelope failures are and some of the locations and how to find out information about that. So if everybody's okay with that, if there are any other thoughts that you have, anything that you'd like me to focus on, please feel free to use your question box and put it in. So let's talk about what a blower door is. So oftentimes we take for granted what a blower door test is or what blower door testing is. We get in there and we just do it because we are sort of need to fulfill some sort of expectation. Perhaps it's a code or otherwise, but oftentimes we don't really think about generally what it is. So blower door is, or blower door testing, it's used to quantify and locate air leakage by using a calibrated fan to depressurize a house. Pretty simple. Of course, we attest to a specific standard depending on who you are so that we can compare one house to another. And that's when we're testing to quantify. But oftentimes we're testing to locate or doing air leakage or doing quality testing, we don't need to. Now I want to start out a little bit with a little bit of explanation and a little bit of sort of a dive into what is a blower door or what makes up a blower door and specifically what makes the Retrotec blower door different or better. First, let's talk about a fan. So airflow across a sensor in the middle of the hub or in the nacelle of a fan causes air pressure. So that's air moving through this across the fan. The manometer, or the gauge, in this case the DM32, compares this fan pressure to the pressure inside the building, and it converts the pressure difference to a rate of airflow. Now the flow sensor, or the flow sensors here, are just in sort of are basically 4 holes in sort of a plastic ring, and that's where they're located. Now you'll notice that with these flow sensors, and this is different from any other fan, that there's actually fins on the other side, and that helps to control, to get you a better, more accurate test so that you don't get air moving across it in this way caused by turbulence or some other effect. So there is an airtight tunnel that's inside the sensor and it connects to the holes, to a hose or a tube coming out of the sensor, and that's located right about here that comes up this way. And it's mounted on the top. So let's talk about some of the fans. Many of you who, let me ask the first question, what kind of fan are you using to test with? So use your question panel to respond. Let me know if you're using an energy conservatory fan, if you're using a Retrotec fan, maybe an Intertech fan, but what kind of fan you're using to test with. Great. Awesome. Wow. So we've got a lot of people who are using, oh wow, we're using some using Retrotech fans. A lot of people, looks like most everybody's using a 1000 fan. Many are using a 5000 fan, and then a few who are also using energy conservatory fans. So we'll talk a little bit about the difference between those. So 1000 fan, which up until just about last year was the standard residential fan, Retrotech, maxed out at about 6,100 CFM. You'll notice that it has an injection molded shell that is very durable, very strong, but much lighter than the previous fan, which was the 2000. The 2000 fan had a shell that was actually filled, and this is why many people think of this fan as a very heavy fan. In fact, it really actually was, but it was extremely durable. Has anybody seen the blower door, or anybody ever seen the video? I think it's on TrueTech, right? TrueTech Tools that did the video. Help me out if anybody's out there, where they actually dropped a fan, I think, from like a second story window.
No, I can help you real quick.
Yes,
it rolled off their truck.
Rolled off
their truck. Yeah, and
right.
They picked it up and confirmed when they got back to the shop outside. They're like, "Hey, guess what? It still works." Yeah.
And Joe, that was a 2000, right?
That was a 2000. Yes.
Yeah. So big, heavy, but extremely strong. No longer necessary. And that maxed out. Thanks, Joe. And that maxed out at about 5,600 CFM. And at that time, or I'm sorry, in the past, also there was the 3000 fan, very similar to the 2000 fan, but was a high power fan, had an additional exterior motor that allowed it to go up to about 8,300 CFM. So now we move into sort of the contemporaries, what the up-to-date newest fans for Retrotech. The 5000 is sort of the standard residential fan, still about a 6,100 CFM. As we mentioned before, has an injection molded fan or shell, much lighter. This is the one that has the nacelle with the fins, which we talked about earlier. It also has a new outer, I believe this is the A-ring. No need to know, because if you're using the DM32, you just look at the shape of it and touch the shape of it, so you don't have to actually know exactly the name. That's held on with hooks. Can be taken off in case you need even more airflow. You'll notice that it also has a pretty obvious shape. That also helps so that this fan, or the fan cover, which is held on with a super magnet, you'll see the magnets here, those actually hold that on, make it easy to pull off and put back on. You'll also notice that now the plugs, the range plugs, have changed significantly. These are the exact same range plugs that are used for the up-to-date, the 300 fan, which is a duct tester. So those are interchangeable. If you're testing something very, very tight, you can use one of those smaller. You can actually plug up all these and use one of the smaller duct tester range plugs to plug up the hole. And then here's its counterpart, the 6000. Generally same size fan, but uses an exterior motor to actually put it up to about 8,300 CFM. And you might be surprised that many people don't know this, but that actually Retrotech does make a high power fan, the 6000 or the 3000, especially when you're testing very, very leaky buildings or very large building, or if you have an application that requires multiple fans. That's a big deal. That extra 2,200 CFM can make a really, really big deal. Anything else about that, anybody? Questions, anything? All right, great. It's a lot of good feedback. Let's talk a little bit about the frame. Here's another thing that makes it different, that makes the Retrotech frame or the Retrotech blower door different. First of all, we actually have a smaller blower door frame that is used mostly for testing a passive house. And this actually fits in a window, so that you don't have to take up an entire door, or if hasn't even been a door installed and maybe there's not a good enough frame in there, you can actually stick this in a window. It's lighter, easier, smaller, and has a smaller hole that's made for a passive house frame. And what we don't see, that's about a 28-inch height, and about a 16-inch width. So what you don't see here is that we actually have a regular sized panel or frame, which also is about this size, 45 max, 97 height, but it also has a smaller hole that can use a 300 fan as a blower door if you're testing something very tight, maybe an apartment or a passive house. And then we actually have a large frame. Large frame goes all the way to 109 height and 51 width. So I don't know if, do we have any people from the South, especially the French South, the Mississippi, New Orleans, any of those folks out there in Louisiana? Anybody out there? Use your question panel to respond. I know many of them have told me that they actually prefer this larger frame because they test a lot of very old houses with very big doors. So yeah, pretty interesting, right, Joe? So the other thing that you'll notice about this is that it actually has little pockets. These pockets are extremely helpful, especially if you're using a 5,000 or a 6,000 fan to put your range plugs in, or any number of things that can be helpful. And it's got a little card there, a little place to put your business card or otherwise. Also, these frames, they snap together. So they're very, very easy to put together. They just snap in together. They're actually just a plastic depressed, point A to point B. And when they're taken apart, you just actually just push them together and they'll just snap apart.
Can I add something there, Jay?
You may.
You have to go back briefly. So I got some feedback saying that, I used to try and take my frame apart by trying to press the button in, and it can be very challenging, or some people using a screwdriver. But as you see in the picture in the upper left, that actually somebody is taking the frame apart and also made it look like they're putting it together. So what you can actually do is you can just take the cloth off of the frame and just kind of make the frame as small as possible, and then just kind of rack it, which means you're just going to tilt it to one side, and it actually will just snap apart, and all the pieces, be careful, they will fall to the ground pretty quickly. But again, I take out my middle crossbars, and I just now have the rectangular frame, just the four corners connected, and I can do that. I usually try and do it, I hold on to the top bar so it doesn't fall on my foot, but that's a lot easier way to just instantly, boom, it's apart, and then you can roll it back up in the cloth for the transportation.
Sure. Oh, thanks, Joe. So I actually have a couple questions here that I'll go through, Joe. And one was that one is, how important is it to have that added crossbar frame? Is there a conversion? So that added crossbar frame you're adding here, so yes, the RetroTech actually has 2 crossbar frames, and you will not see that on the Energy Conservatory frame. How important of it is it? Well, I think it's extremely helpful, especially if you're working in retrofit, when you really have a problem with some of those weird shaped doors and some of those doors that just aren't as strong. So this makes sure that it's fitted in there it fits in there very, very tightly. And then you'll notice that this extra piece of Velcro here can help you to hang your gauge on. Can it be used with Energy Conservatory fans? Absolutely. Had plenty of people who have seen this in real life, seen the way that the calipers are built, and some of just the absolute the hardware that is built on this, or that's added to this, is much more durable, much stronger. Seen that it's much lighter. Love the way that the connections fit, but didn't want to fully upgrade or wasn't ready to buy a complete system, and have actually purchased one of these. The other question, I guess, was, someone mentioned here, Eric, thanks a lot, mentions that big doors are common on large vacation homes and ski resorts. Let's see, is there a conversion? I don't know that there is a conversion for, if you're talking about Energy Conservatory fans. I don't know. Sorry about that. Yeah, so taking these ones apart, very, very easy to do. It seems scary at first, but all you need to do is take these crossbars apart. So these are always the last to get installed, and always the first to get taken out when you're actually taking it down. But once you've taken those down, you can actually take this frame out and just kind of push down on the corner, any one of these corners, and it'll actually come apart for you immediately. So it's actually really nice. And then someone asked how the frame is, or how the panel is attached to the frame. Actually, this is just a picture. You don't see the overlap. So that the panel actually overlaps just as it would in any blower door that you've ever seen before. But for this schematic, this picture, it actually is, that part is taken out, so you can see it's a great question. So let's not forget about a unique frame, the hard panel, which is unique to RetroTech, which doesn't require a frame. It actually is, it's a modular panel, and it installs just as you can see here, that basically you have these these pieces that slide And all you do is you take this, which is essentially this yellow part right here, which is essentially a handle. You pull it. When you pull on that, it tightens to the side. And then when it gets tight enough for you, you just stick it down to this piece of Velcro across, and that's it. So you put the bottom one in, you put the top one in, and then you put the middle filler in there. So you've got the A, the B, and the C. And then you've got a nice, solid, really professional looking modular panel, and you can use it for a double panel as well if you like. And then when it breaks down like this. This is great for folks that are working in retrofit. I love this thing. This is great. Obviously, it makes you look professional, but it is so much easier to install in a home that's got, you know, stuff in the foyer, that's got a lamp hanging, you know, and it's just much easier, much more professional looking. And it's an engineering marvel. So then the other part of that blower, actually I'm going a little bit, maybe I'm going too fast. Let me take a look to see if there's any questions here. What's the maximum CFM on a passive, on the blower door, the maximum CFM on the passive house one? Well, that is actually that's a duct tester. And I would have to look.
I can help you with that answer.
Thank you.
I already did. That's why I'm in the background. So if you're going to use a duct tester as a blower door, and in the gauge it actually has a list of blower doors, and it shows duct testers in there because Retrotech understands that when you don't have the flex duct connected to your duct tester, you have more flow and more ability to get more CFM out of it. So they actually have different fan curves for using a duct tester as a blower door. So the answer to the question is it'll do around 760 CFM at 50 pascals, which that kind of back pressure. So again, 760 CFM using your duct tester as a blower door.
Thanks, Joe. So Joe, I'll let you, yeah, looks like you've got some of those in the background. He's already typing that in. So Joe's on it in the background. If you have any other questions that we can't get to in the, you know, within the confines of this particular webinar, we'll definitely follow up with you. So the other components, we talked about the fan and we talked about the frame. Well, the other thing is the gauge. And the gauge is really, especially when we're talking about here, the DM32 gauge, this is really the biggest, most important part to all of the Retrotech family of equipment. So the gauge is one that brings it all together. So the gauge, the display on the gauge is a touchscreen display. So anything that it's pressure operated. Channel A is on top. Channel B is, of course, below it. Channel A will give you the units that you want to test to. Channel B will give you the results that you want. I'll talk a little bit in a second here about what results you can get. Also, just to the left here on Channel B, you'll see that your device and that your configuration is there. So this is the device range is right there. So you'll see that you can also your time average is on the top in the middle. Fan speed is there. Also unique to the DM32 as opposed to a DG700 is that you can actually see fan speed, which can be very helpful, especially when you're trying to figure out what is going or some difficulties or obstacles that you might have while you're testing. So it is a touch screen. If you want to change the range, you simply touch the range. So here we're talking about a 200 duct tester, but all I did there was I actually touched that screen. And for some of you out there, there's a difference between a pressure sensitive screen and a capacitive screen. The capacitive screen is the one that we're most common, that most of us are familiar with from our mobile devices, where it actually picks up on the electrical or the bioelectrical from your hand or your body. However, this is a pressure-sensitive screen because we thought, well, or I should say but I meant to say Colin, Genge, and Retrotech thought there's probably guys who are working where they might have gloves on or they might not want to smear, so they might be using a device to touch the screen. So it's pressure-sensitive. But all you really have to do if you say, oh, I want to change the range, I just touch the screen. If I want to change the configuration, I touch that. And that's easy, so it's really as simple as that. And like I had mentioned earlier, I don't have to know the name. I don't have to know open, mid, low, A, B, C, or any of that stuff, because all I have to do is just look at it and touch the picture of it. So here you also see some of the other devices that were available if I wanted to change my device altogether. Instead of just changing the range, these are the ranges and devices that are available for the 1000. And here I've picked, again, the B range configuration just by looking at it. So with the 5000, you'll see it's a little bit different. So here's an idea of what, here's your screen that you would find if you went into the blower doors. These are the ones that are available. And as Joe mentioned, you'll notice that the 300, which is a duct tester, is actually here on the blower doors. So that's because, like Joe said, it's got a different, it's a different flow curve when it doesn't have the flex tube attached to it. So it is in my blower doors. If I'm using it as a blower door, then I choose this one rather than the 300 that I would find in the duct tester listing. My 1000, 2000, 3000, 3000 SR, the 5000, and the 6000 are all available here. So all I do is I say, well, it looks like this one, not like this one. I touch it, and then I'll get my choice of configurations. So as I had mentioned earlier, the 5000 uses range plugs that are the same as the ones that are used in the duct tester, the 300. And you'll notice if you're testing a very tight building, you can actually use some of these smaller range configuration range plugs. And those are available as an add-on. Same with the 6000. You'll notice that these are all very much, it's very similar. The configurations, just a stronger, bigger fan. Now let's talk a little bit about test results. So you have a wide variety of test results. Any results that you need for any application, you're going to be able to find in the DM32. And again, it's as simple as touching it. So here I touch my screen, and then it takes me to results to be displayed. And then you'll notice that I have quite a bit of choices just on the first screen, but there are more screens. So here I have this sort of 3 dots. I think that's an ellipsis. I touch that, and that's going to take me to my next screen of results to be displayed. So you'll notice that you can see EQLA, EFLA, and then if you're actually testing, is anybody out there testing that's more interested in metrics or as opposed to imperial units? If so, all you do is touch it again, and then you can find the equivalent of that in a metrics. So I can either touch my back arrow or my home button to take me back, and now I've changed to whatever results I want. So it looks like there's a lot of questions out there. Joe, do you want to take a second to verbally answer any of the questions on here, or should I keep going?
I would say right now just go ahead and keep going. I'm trying to actually. I do want to mention for folks that I'm putting stuff in the handouts. The handouts is in your control panel, and I got 3, and I'm going to put 2 more documents in there. You basically can just tap on them, and they automatically download for you.
Oh yeah, good point. Yeah, so look on your control panel, folks. Down at the bottom it says handouts. If you maximize that, all you have to do is click on any of those, and those will be, you have the manual for the blower door operation, the manual for the multiple fan operation, and the quick guide for the blower door 5000, 6000. Thanks, Joe. So yeah, we talked about results or getting the test results that you want, but let's not forget that you can also change the units. So for those of you who are maybe using this this gauge for other than blower door testing, or if for some reason you want to test in anything besides Pascals, I've never heard of it, but that doesn't mean you can't do it. In fact, you can. So you can actually change the units that you're testing in, but in this case, we're actually going to touch settings. So if you just touch this area, if you just touch the A channel, this will actually hold. So now if you actually want to change the units that you're testing in rather than the results that you want to receive, then you actually want to touch settings. So once you touch settings, now you can actually go in here and change the pressure that you're testing at. You can test in water column inches, you can test in PSF, it's up to you. So those are things that are just available to you, and you can see this is what it looks like. Let's not forget, also I know that I had a few people out there that mentioned that they're using energy conservatory fans. The DM32 also will control any Minneapolis fan, any Energy Conservatory fan, or you can see the exhaust flow meter, the true flow grid, or duct blaster. Any of those things it can actually control. So you just need an adapter. As well as the fact that, although I do not know, I think what the trade-in is for it right now. Again, I'm a private contractor. I do know that up until the end of the year, RetroTech will offer you a trade-in value for your DM2 or DG700 as long as they work. You can actually trade them in and get that trade-in applied to their DM32 smart gauge. So of course they don't just buy it from you just to buy it. They will give you a trade-in value and apply that to a new DM32 smart gauge. So definitely, if you have any questions about that, I highly recommend go to retrotech.com, call the sales and support team, and ask them about that. You have something, Joe?
Sorry, no, I left my mic on by accident. Go ahead.
That's cool. So why test? Again, it seems like we do a lot of testing, but a lot of people don't realize why we test. Joe's going to come up after this and talk a little bit about codes, about testing the code, which I think is a very, well, not just important, but a very popular part. Programs, when I talk about programs, I mean utility programs, low-income weatherization, any of these other programs that are set up for energy efficiency, comfort, health and safety, those type of things. And then control. So we're going to talk a little bit about code. Please let us know how interested you are in that if you want us to. And again, Joe's going to talk about that. Code official, he's an expert on it. And then I'm going to talk a little bit about control. And when I say control, why are we testing? Well, we're testing to make sure that our shell, the building shell, can control so that we can be more comfortable, more energy efficient for durability and for indoor air quality. But I'm going to hand this over to Joe. And Joe, do you want me to use my slides, or do you want to flip over to your slides?
Go ahead and use my deck.
Okie doke. And I'm going to hand off to you, Joe.
And I'm looking for the.
Yeah. So while Joe's setting that up, Joe, I'm going to answer a couple questions while you're getting set up.
Yeah, good.
Looks like you're ready to go. So metric, yes, good. Yes, definitely this gauge is set up to test both in imperial units and metric units. It also comes it has French, Spanish, and English, as well as Joe might have to help me with that. I believe some of the language there's the other language. I think it's Polish as well. Is that right? I'll have to check on that, but definitely French, Spanish, and English. So it also is available in other languages. Pros and cons versus soft door versus hard door. Pros and cons, definitely the hard door is easier to use. It is quicker to put up. It is much more professional looking. The con is that it's only going to get it only gets so small, so it can be a little bit heavier and a little bit more difficult to move around. But Joe, looks like you're ready to go.
Yeah, so a couple people want to say, like, hey, what's it look like or how does it function? So I just added a slide real quick, and it's going to be an animated sequence that'll go pretty quick. So here we go. So this is how a blower door gets set up and how it's used. So we're going to go through the whole scenario kind of briefly, and I'll actually do a voiceover as we go. So that's the cloth panel, how you transport it. It comes with all of these amazing quick guides that Jay's been mentioning, and here's how simple the frame snaps together. It is labeled so you actually can make sure you keep track of the corners. And normally, as you've been doing blower door, it's a similar concept of loosening the knobs, making sure I fit it into the door with a little slight gap so I actually have room to come back. When I put it in with the cloth, you do get 2 crossbars. One crossbar is designed to hold the fan, one crossbar is designed to hold the gauge, but it does allow and provide an enormous amount of stability to your unit. It'll go up to around 97 inches tall. I think it's 42 inches wide. And the bottom's got a little track or a little slot where you can put the frame into. Now my son Jack's putting it in the window, securing it. These are all common procedures we either recommend or you should be doing it. You know, pushing your thumb across the crossbar and tightening it, engaging all of the cams that are around. Whatever system you use, I always encourage you to follow that exact same one every time and pull on the frame to make sure it's not going to pop out. You do get a little lunchbox style case that holds your gauge and all of the tubing that goes along with it, and the umbilical, which has all of the color coding connections that go from the gauge to the fan. It's held in place. You have a cover, the bottom. So we actually, our system is yellow to the yellow fan. All of the fans are yellow. Red always goes through the red cloth. You make your connections, and there's a place to hold the gauge right there on top. I provide power. There's an on-off switch. And now I'm going to set up the DM32, which initially when you turn it on, it will actually go to the exact same place where you left it off. It's an amazing, simple feature, but it's very helpful. You can tap baseline, it'll acquire the baseline, and then you can set the baseline. The new system, this is the older 1000, the new one actually has only an A, B, and fillers that go along with that. So we recommend people do a set to 25, check to make sure no loud booms, nothing happened, and then you get your results as you need them for at 50 pascals. So hopefully that gives you guys a quick overview of that, how that system works. It looks very similar to your older systems or to the Energy Conservatory. There are some more powerful features in terms of how useful the gauge is and how easy the frame sets up and takes down. So we did do a whole thing on this, and it is on YouTube, about the blower doors and codes and some of the challenges. I'm going to just do a brief review of the differences. So some people may be on 2009 and doing blower door. We are in Georgia, we do that. Or you may be adopted to 2012 or even the 2015 and trying to adapt to how the blower door is testing. So for the first time in the official code book was 2012 requiring blower door testing. And it actually was very controversial in terms of how what his requirements were, because they were just a basic test. It didn't even require a baseline. So there's a lot of things that it was missing. It didn't have anything about how accurate your equipment needed to be or how to really set up the house. A lot of things were left as gaps in 2012. 2015 decided to just refer to another standard. So 2015 says you can either use E779-10 or E1827-11. Those are ASTM standards that are not easily followed or very challenging. They're more of an engineering kind of a document and make pulling out your gauge and doing a test for 2015 a little more difficult. So in order to do a 2015 code compliance blower door, you need software. It's just that simple. Here's the kind of stuff that's happening is that we went from a single point, just turn on your gauge, take the fan up to 50 pascals, get a reading, and we call it done. The 2015 is requiring either a multi-point test. So this kind of explains that the difference between a single point and a multi-point and why it's a little more challenging to do this on your own. These are some of the basics that come into play when you're dealing with either one of these standards. So, you know, you both have to collect a various data. One actually requires that you pressurize and depressurize and various induced pressures from a range or repeated the same test over and over again 5 times. All these things are difficult to keep track of or just write down and then add all of the math that goes along with it. So these are some of the basic calculations that are required and how confidence levels are evaluated, analysis of precision or errors that could be implied. It looks kind of like this. So if this is the kind of stuff you can do on in the morning after you eat breakfast or things you do in your spare time, definitely not something to be done on the road, then you probably can figure out an Excel spreadsheet to do it. It's way beyond my ability to calculate the results of either of these tests with this kind of math running at you. So there are some solutions that are out there. Our cloud, which has just been fully released and it's on the Windows Store, will do this test automatically. So there are ways to do it. Right now we're updating how it shows up for the ICC code, but you can use a ResNet standard to follow this type of same process. and basically allows you to open the app, pick a blower door or duct test. So clearly we would pick a blower door test, and you get some options in terms of whether you're going to follow a ResNet standard, the ICC, or a Title 24 for those of you that are in California. The ICC is still, the current version only has the standard 1-point test, but we're right now got the app stabilized, and now we can update that. But ResNet does have the ability to do a multi-point or a single point or repeated single point, so you could use that for your code compliance. Another option is Fantastic, also does this completely automatically. It'll just say find my gauges, run the test, and will tell you what your results are automatically without any of the challenges that sometimes go along with more complicated software to try and do this, or importing data from one application to another. This just says pick your test, and you're off and running. So this is the main kind of screen that I would have. It actually will determine automatically if you're pressurizing or depressurizing, and you can download Fantastic for 30 days and run as many tests as you want and do everything you want to do. After 30 days, you can either use it for a single fan, but you don't get any report writing, or you can upgrade to get something that will do report writing as part of that. So the free version is 1 fan, or you can go from 2 to 24 depending on your requirements you're needing, and pick one standard that will work for the main guidelines that you're after. And here's your different versions between Lite, which is free, and the Pro. And so once you get to a Fantastic Pro 6, you can run multiple fans if you're doing multifamily or things that are a little more advanced than that. So this is a slide that Jay added quickly about the updated code requirements. And what is a challenge sometimes when you find these is that your state may be, well, this is what's on technically, is that they adopted 2015 or 12, but they have other individual adaptations or modifications that actually say, well, we do this, but we don't do that. So if you're out there, help us out. So what state are you in, or county, and what is your requirement for blower door? Many people have been doing duct testing for a while, but we're trying to get a snapshot on who's doing what for blower door. So if you could let us know, again, what state, sometimes counties are different or cities are different, and what is your code that you're trying to meet, and what is the actual number that you must comply with. Here in Georgia, we're actually at 7 air changes per hour. Some folks are at 4, some people are at 5, some people are at 3. And depending on your construction type, that can be a very challenging number to meet or compete with. And I guess the other question as a follow-up is, even though you may have adopted these codes, do you actually have compliance? Which means, do you actually have a code official confirming that these are required, and making sure that either your paperwork is done, or they verify your results in terms of some type of documentation, or they visually come to the job site. So a lot of places are saying, oh yeah, we're on the books for this, but it's not actually something anybody's participating with, because they just know that there's no oversight or no code compliance really. So here's from 2012, when the very first code required blower door testing. And depending on where you live in the ASHRAE kind of standard climate map as to what your requirements would be. So it's either 5 air changes per hour for climates zones 1 and 2, or 3 air changes for 3 through 8, which is the majority of those listening to us today, and I'll kind of show you what that looks like. So here's the climate zone map, and you can see that 1 is mostly just kind of like Miami and the tip of Florida. It does include Hawaii, Puerto Rico, and those places that actually use this code as a compliance path also. So if we just look at climate zones 1 and 2, these are the places that are adapted to 5 air changes per hour, and the reality is, here's the rest of everybody who is trying to get to 3 air changes per hour, and a lot of things are changing in terms of this number. I know many folks are going to 4, some places are going to 5. They're readapting what is a multifamily or a smaller combined unit. In terms of maybe it's a condo, those are actually being altered, or they're doing a different path than air changes per hour. So if you are aware of some of the different options that you have, that'd be great. And let us know if you're having challenges, because 3 air changes per hour with a home that's on a slab, you really got to be on top of your game. There's not a lot of volume there, and it can be really difficult to achieve that number. I highly encourage you to test early and often when you're first starting this with a builder to make sure you're finding some of the errors. And again, all this can be totally revamped based on your exceptions and local adoptions. Here's one that we do want to promote, because one of the things that happens is not in the code clearly is who can do the test. Many, again, local adoptions say that you can be a HERS rater, you can be the builder, you can be a BPI analyst or envelope or auditor. And here's one that BPI decided to make sure they focus specifically on the code compliance, and that is that they call it the IDL, the Infiltration Duct Leakage Certification. This is a field exam only, which means you just have to show up and show that you're competent to run a blower door and a duct tester and perform the test. And most people would finish this in around 30 minutes. A lot of times they come with a class that's earlier that day, so you can get a refresher on how to use it. And this is probably going to be the #1 compliance certification that mostly just focuses on new construction, code compliance, how to use equipment. It's not about doing diagnostics. It's about how to confirm that this structure or these ducts, this house, complies with the code. So it's not about anything to do with existing homes. It's only a new construction type of certification and application. I'm going to turn this back to Jay, because this is one of the things that Jay, when he came to us, brought to us, is how to do a national manufacturer certification. And it is an amazing resource that RetroTech has been able to do. And Jay, you ready?
Yep, I think we're up and running, right?
Yes, you are. Yep.
Yeah, so Joe mentioned that the IDL course doesn't have any training. It's a field test. This is a place where you can get the training for it. I want to make sure that everybody knows that if you've bought a system, a RetroTech system from RetroTech or and any of the resellers knew in the last year, that you are entitled to a national manufacturer certification. If you want additional ones, they're relatively inexpensive. I'm not real sure exactly how much they cost, but I don't think they cost much. So it's very, very cheap, and it's a good way to make sure that you actually know how to use the equipment that you've purchased. And then if you want to take one of those certification tests, or even if you're not testing for that code, if you're not looking for a certification, an IDL or any other certification, if you want to just make sure that you can actually use the equipment that you have, that you can take this for free online. It's very short and relatively specific, I shouldn't say relatively, it is absolutely specific to the equipment that you have, so there's not a whole lot of wasted time. So thanks, Joe. I think it's important to point out, and by the way, that is my real name, so it's not, don't call my house. Don't send me any more magazine subscriptions, please. So so Joe mentioned that a lot of talk about ACH 50. So for those of you who don't normally test with the DM32 at ACH 50, or who don't use the DM32, just want to give you an idea of how you would switch. So here's the normal setup that you would have for a ASTM 779. This is the most common, I think, in the United States test. It's 50 pascals testing for CFM at 50. So this is how it would be normally set up, or if you were testing for that. Again, very simple. You just touch the CFM, you press down on it, then you'll see this screen come up. Then you just press ACH, and that's going to, and then touch that home button, and that's going to take you back to home, and now you see it's ACH. You want to make sure that your volume's set, though. And Joe asked me about this, so I'll get into a little bit about in a second. But also want to let you know that you can do that while the fan's running. So frequently, just out of curiosity, I'll actually be running a test at CFM 50 and be curious what the ACH number would be, and just touch it and change it. And then sometimes even we'll switch over to EQLA, which I actually will mention in a second here as well. But you want to make sure that you have the volume entered. So the way to make sure that your volume is correct, because of course ACH is air changes per hour, and that's air changes, and that's always going to be dependent on the volume of the house. So the way to do that is, and that's how you can find out what volume it's seeking. So that's while you're running the test. You'll notice that we have this, that we have these colorful control buttons that come up as you're running a test. So that's when you see that you're actually, you've set this to run at 50, and it tells you that it's seeking 50 for the volume of 1500. Here's the other place that you can find it when you're not running a test. So that's how you know what volume. So you hit settings, and then once you've pressed settings, then you're going to come to this screen, and there it is, simple as that. There's your volume. So in order to change that volume, I'm going to press on that, physically press on that, and then it's going to give me this pay or this screen so that I can change it. Joe, is that answer your question? So as you said, you wanted to know, can I clear it? I just hit clear. That'll bring me to 0. Then I type it in. I hit set, and then I'm good to go. And then it'll take me back to my screen. Yes, sir.
Just to interject there, from the home screen, you can simply tap on area or volume and change it right there. It will go to that screen. You don't have to go into settings. I didn't know that. I just tried it.
Yeah, the difference is that, here, let me help you. So the slide, I made this animation. So the slide on the left is from the home screen. You can't tap on volume, which is right below the image of the fan. But if it's running and you want to do it, then you have to go through settings. So that's the try to animate both at the same time. So one you can do from the home screen, or while it's running, you go through settings.
I didn't know that. So you're saying if it's running, you can't tap on volume on the home screen?
No, because it's not there. It actually has, see the green arrow up and down takes over that.
Oh, okay, okay. So only prior to starting the test can you do that. Yeah, okay, got it. Thanks, Joe.
Sure.
Thank you, Colin. I'm glad you joined us. Time average, also a big deal, can be useful. Some people like a long time average, some people like a shorter time average, but once again, you can't just touch that and change it, because that's going to give you, you're actually going to hold, it's going to stop and freeze the screen for you. So the way to change that, to change your time average, pretty simple. We just go into settings. From settings, you'll see the time average. You can touch that time average, and I may have accidentally bunched it. Yes, and you get a choice: 1 second, 5 seconds, 10 seconds, 30 seconds, or manual. If you go to manual, you can change it to anything you want. In this case, Joe, who also made this very, very nice slide, chose to go to 120-second average. So
that is the max. The reason that's the max you can do.
Okay.
It's a 2-minute baseline. Yeah.
Thanks, Joe. And this picture of this man's derriere here is to show us that you can also use approximate leakage area. So I want to kind of use that, I think, to sort of basically start to finish up this presentation, but to tell you that you can also, there are also some results that you can use that are useful just for explaining things to people. They're not necessarily the results that are called for by code. They're not the results that are called for by any other unit or program, but just something so that you can actually talk to people about. The best one, the one that I like the best, and is the approximate leakage area. So the approximate leakage area is going to tell you in your gauge. Now, again, this is something that you would choose in your gauge. It's going to tell you the approximate hole that you would have if all of the leakage, all of the bypass was added together. So this is, again, this is, I guess, right after you got done with your breakfast and you did all, you wrote out your multi-point test on your, with your pencil and paper. You could do this next for dessert. You could do this if you wanted to. However, this is right in the gauge. So again, this is great because, and as this picture shows, you can talk to someone and say, anybody, and say, well, you're not going to talk about CFM. They don't know what that means. But what you can say is, this is the equivalent size hole that you would have if it was all put together. And it's about the size of a medium-sized or larger-sized man could actually climb through. So I think we're just about at the end of time here. Does anybody have any questions? Anything else, Colin, that you'd like to add? I have.
Yeah, they had someone was asking me about passive house leakage, and I just did a calculation for 10,000 cubic foot house, so it'd be like 1,200 square feet. The maximum allowable leakage is 100 CFM, which is amazing when you consider that passive house requires the entire house to leak less than the duct systems that we have that often can leak over 100 CFM. So passive house technology can get the entire house down to less than 100 CFM at 50 pascals. So there is almost no end to how good these houses can perform. So just a matter of technology. I can't think of anything specifically. I'll just run over the questions here again.
I have one. Someone says they wanted to know, and I'm typing up the answer now, but it says, what's the most common time average reading? I recommend 10 seconds. And one of the things that you want to keep track of if you're using time average is that before you take or calculate or read your final reading, that you want to wait at least twice as long as whatever your time average just changed to. So I'll give the example. Let's say we set it for 30 seconds. And that means that I now have 30 seconds where maybe I wasn't up to speed, or I just turned the fan on and I have readings that are part of that average. So the best thing you could do is at least wait twice as long as your time average before you say, okay, that's my final result. That you have other readings that, if your fan was running slower, are not part of that average or that reading. Hopefully that makes sense.
I had another question there where someone was asking if they have a super high door, can they get just the side pieces and extend the height of their frame? And the answer would be yes, they fit. If you've got the new style click-in corners, you can get longer verticals if you'd like to get longer verticals. I can't remember ever having sold one, but there's no reason why we couldn't do that. So just contact sales, and on our website there's an 800 number you can call, and you can discuss it with them.
Someone asked about a cheap tool to record building pressures. There are a lot of laser measurement tools out there that you can get for usually under $100 that can actually calculate room volumes by pointing it, 3 different ways, and it'll tell you what that room volume is. And there's very few that actually can go through a whole house and keep adding them up. But that's one source out there.
Right. Another person asked about how important the crossbars are in the frame. On the new regular frames, we have 2 crossbars, and the large frames we have 3 crossbars. And the reason why that's important is the upper part of the frame around the window, there's only 1 crossbar, gets a little floppy. So the added crossbar really improves that situation. Also gives us a nice convenient way or place to mount our gauge, so the gauge can be mounted on the crossbar in a number of different places. Also in the new frames we've riddled the thing with slots, so you can put the crossbar at any one of like a dozen different locations to get a really nice frame setup.
Well, all right. If any other questions out there, anything else that you'd like to know about? Oh, and I did want to make sure that I was clear about one thing. I mentioned earlier the languages that are available in the DM32 right out of the box, standard off the shelf. It was actually German, so it is Spanish, French, German, and English. Sure. All right. Well, if there's nothing else, if there's anything else that you've thought about that that you didn't think of now, or anything that we didn't get to, please feel free to email me at jwest, J-W-E-S-T, at retrotech.com, or Joe, J-O-E, at retrotech.com, or you can always send it to training@retrotech.com or marketing@retrotech.com. We always we get those as well. And then, yes, as Rick wants to know, that it's difficult to answer questions. Some of these questions we'll have to send Rick your answer to your question directly. Right. All right. Thanks everybody so much once again, and we'll see you again soon. Have a great summer. Bye-bye.